Hello everyone, today we will be studying the components, types and structures of suspension systems. Mission statement. When Mr. Wang's Geely EV450 is driving on a slightly bumpy road, the chassis has a thumping sound. After the service advisor's inquiry and inspection, the vehicle is handed over to the service technician, who checks the suspension system according to the service manual. There are two learning objectives. 1. Familiarize yourself with the role and components of automotive suspension. 2. Ability to recognize the various types of automotive suspensions. Next, let's learn the first part, role and components of automotive suspension. The role of automobile suspension. Automobile suspension is the collective name of the elastic coupling device between the frame and axle. Its role is to elastically connect the axle and the frame, moderate the impact of the vehicle on the road, to ensure the integrity of the goods and personnel comfort. Attenuation of vibration caused by the elastic system, so that the car driving to maintain a stable posture, improve the stability of the maneuver. Components of the suspension system: elastic elements, damping elements, guiding elements, and lateral stabilizers and other components. As shown in the figure, these elements share the task of transmitting various forces between the wheel and the frame, and play the roles of cushioning, damping, guiding, and transmitting forces and moments respectively. Part 2. Types of automobile suspensions. 1. Types of automobile suspensions. Vehicle suspension structure. Categorized into independent and non-independent suspension. According to the different elastic elements, they are categorized into coil spring suspension, leaf spring suspension, torsion bar spring suspension, and gas spring suspension. Self-adjustment of suspension system parameters. There are passive, semi-active, and active suspensions. By type of axle the suspension sits on, they are categorized into steering axle suspension, drive axle suspension, and follower axle suspension. 2. Independent suspension. Independent suspension is where the wheels on each side are independently and elastically connected to the frame, as shown in the diagram, so that when a wheel on one side is impacted, its movement does not directly affect the wheel on the other side, and the axle used for independent suspension is disconnected. 3. Non-independent suspension. The non-independent suspension is shown in the figure. It is characterized by the two sides of the wheels mounted on the integral axle, when one side of the wheel will be directly affected by the impact of the other side of the wheel. When the wheel bounces up and down, when the positioning parameters change little. For front suspension, the front suspension of all axles is independent, and the two common types today are double wishbone independent suspension and strut independent suspension. Double wishbone independent suspension. It generally consists of upper and lower control arms supporting the steering knuckle equipped with the axle, and the shock absorber is installed between the upper and lower control arms. It is possible to set the length of the control arms freely to make the automobile have good cornering performance, straight line driving performance, and ride comfort performance. Strut independent suspension. Because the shock absorber doubles as a suspension strut, this is referred to as a strut suspension. When used for the front wheels, it becomes a MacPherson strut suspension, and when used for the rear wheels, it is known as a Chapman strut suspension. 5. Rear suspension. A typical sedan's rear suspension is often a torsion beam non-independent or multi-link independent suspension, and some cars will have a double wishbone independent suspension or double wishbone independent suspension. Torsion beam non-independent suspension. Torsion beam non-independent suspension, the most common rear suspension structure for entry-level domestic and joint venture vehicles. Advantage. 1. It is also not easy to change the angle of the wheels when the height of the body is lowered. 2. Simple structure, low manufacturing cost, easy maintenance. 3. Takes up less space and reduces the height of the car's floorboards. Disadvantages. 1. The left and right wheels can interfere with each other when bouncing, reducing ride comfort and maneuverability. 2. Simple structure allows less freedom of design and less stability of operation. Multi-link independent suspension. Multi-link independent suspension is composed of connecting rods, shock absorbers, and shock-absorbing springs. It has more connecting rods than the general suspension. It is generally referred to as a suspension with 4 or more connecting rod structure, called multi-link. Advantage: multi-link independent suspension not only ensures a certain degree of comfort, but also, due to the large number of links, keeps the wheels and the ground as perpendicular as possible, minimizes body tilt, and maintains the tires on the ground as much as possible. Disadvantages: multi-link suspension structure is relatively complex. The cost of materials, R&D experimental costs and manufacturing costs are much higher than other types of suspension. And it occupies a large space. Small and medium-sized cars for cost and space considerations rarely use this suspension. Double wishbone independent suspension. Double wishbone suspension, also known as double arm independent suspension, in fact, isn't the McPherson suspension on the basis of a fork arm. The main role is the wheel steering force are borne by the fork arm, and the shock absorbing part of the original is only to undertake the task of shock absorption. Advantage: high lateral stiffness, excellent roll resistance, good grip, clear road feel. Disadvantages: high manufacturing costs, complex setting of suspension positioning parameters, more complex technical maintenance. Double wishbone independent suspension. Double wishbone independent suspension is divided into equal length double wishbone and unequal length double wishbone according to whether the upper and lower wishbones are equal length, as shown in the figure. Advantages: the double wishbone independent suspension has no lateral loads on the shock absorbers and has a lower height at the top end, which helps to reduce the height of the front end and improve the body styling. As a result, this type of suspension has good handling stability and comfort and is a more advanced type of suspension. Disadvantages: however, double wishbone independent suspension also has some disadvantages, such as complex structure, high cost, take up more space, and so on. Alright, that concludes this lesson.